Okay, hello everyone. So I recognise a few faces in the room, but obviously we've got some new customers here. So Hannah Lawrence, and I work as a Senior Sustainable Transformation Technologist. That's a mouthful, so what does that mean? I work as part of the Living Progress organisation here at HPE. So as a sustainable technologist, my role is I speak with customers pretty much every day on how they can actually start to reduce their carbon footprint and drive efficiencies within their current infrastructure. So we're going to dive in. So the AI era, it comes with lots of challenges, as we've been talking about, and new opportunities. And I think for me, looking at what we read in the media and in the news, I think we should sometimes take it with maybe a bit more than a pinch of salt. I think there are lots of positives with AI if you do it sustainably and you do it with efficiency in mind as well. And some of the new kind of opportunities I think are great if you think about the things that are happening in healthcare or the positive things around that in terms of cancer detections and other things around mental health and all the positives that it can bring there as well. But of course, AI in this era, it comes with a massive data growth. And what does that mean? All of that data needs to sit somewhere. It's going to sit somewhere, it's going to consume energy, and it's going to heat up those data centers. So that's a lot in terms of energy as well. So cost and heat and all of that. So that's why we need to make sure when we're doing this and we're going on this journey, if AI is the answer for that particular solution, we're doing this sustainably and efficiently. So, as again, I think we've spoken about just now, AI is transforming pretty much every single industry. I think it's a very exciting time to kind of watch this kind of unfold, but it is difficult. So we actually see that only about 10% of AI solutions actually make it to production, which I think is a really small stat. And that was actually from a particular Forbes article there. But as a team, the team that I work for, when we speak to customers, this is around about the stat that we see as well. So I think customers are getting very excited, and I'm very excited to speak to you at lunchtime as well to see what's been going on. But I think you get excited and actually they don't have the foundations in place. And what do I mean by that? So maybe this is not a surprise to people, but a lot of customers, they don't actually have an AI implementation strategy. They don't have an AI strategy in place. So that's something that we as a team identify and we can help customers with. Another thing on top of that, as well as how can we actually help customers get more actually and make it to production, implement an AI strategy, help them with the AI implementation strategy, but also make them start thinking about AI ethics, doing responsible AI, and also looking at areas around efficiency, how they can do it efficiently, and also thinking about the regulatory compliance as well. Now, on top of that, we've got lots of things happening, and this is all happening at the same time. So we've seen lots of new infrastructure requirements, so increased power density. So normally the average workload and what we see in terms of racks for an enterprise workload is normally about 4 to 6 kilowatts per rack. And when we look at AI workloads and AI solutions, we're looking around about 100 plus. So what does that mean? That essentially means that, again, the density of that is going to generate a lot of heat, and it's going to be very intensive in terms of resources to actually operate that. Need for liquid cooling. So one of the things that we are seeing here is actually, if you look at chip processors, roadmaps and iterations for the next few years, it's actually going to come to a point where they're not only going to recommend that you might need to go down the direct liquid cooling path, they're actually going to require you to do so. They're going to say you're going to have to do this. Why? Because the changes that are happening, in order to cool that infrastructure down, you're going to have direct liquid cooling in place in order to do that. And last but certainly not least, power and carbon measurement. So again, this is something that we see, and I speak to customers all the time, and they're needing some help on how do we measure. You know, you've got all these regulations coming in, again, that was mentioned. How can we actually manage our power and carbon properly and effectively? What tools do we have in place? And we've got lots of tools that we help with customers to make that life easier for them. And this is something, again, it was just touched upon, but globally, we're seeing this increase. So all of these regulations, they're going to keep coming, and more metrics are going to need to be tapped into and recorded. So I wanted to add a bit of a visual here. I am a visual learner, and I wanted to just show you what's kind of been happening in terms of what are the standard ways in which models can be or are being designed, sorry. So it started off that usually when models were designed and created, AI models, they started off kind of following this particular curve and trend. So when you look at this, it's almost as if a developer said, imagine you've got unlimited resources, you've got unlimited power, you've got unlimited everything, and I want you to create the biggest model ever. I'm being kind of, tongue in cheek, but that's what it's almost kind of happened. And then we saw, I think it was not so long ago, actually, maybe about 5-6 months ago, if you look in the bottom right-hand side, if you didn't see that change, we saw DeepSeek pop up, and that was around, I think it was 6 months ago, around about that time. Now, I personally hadn't heard of DeepSeek, and I think a lot of people would agree with me. They just kind of popped up out of nowhere. And what they did was actually, they were working in the background quite quietly, quite cleverly, and they demonstrated that they could create smaller models with less resources, less power, less energy, and they were just as accurate. And the positive thing about this is actually it's brought the word efficiency back into the conversation. So now we know that we can actually create models with efficiency in mind. So it's a positive, and this is exciting to actually watch what is going to happen. The thing I'll say on this as well, of course, is whether you go for a large language model or a small language model, it completely depends on the ask and the requirements. But this is something that, again, we get excited in our team because it's bringing efficiency back into the game. So I added this in last minute, actually, but I did just want to highlight, I know we're here talking about AI today, but I did want to highlight just this nice graph from the Uptime Institute. And what this shows is it's the global data center energy consumption from the year 2023 to the year 2030. And in the blue there, if you can't see, that is standard compute. So that's all of the standard compute workloads and how much energy that's consuming. And if you look on the far right-hand side, the orange and the green, that is AI training and AI inferencing. So I say this because, yes, in the media and the news, and why we are here today is to talk about AI, it is consuming a lot of energy, but the prediction and what this particular article shows, and I could share it afterwards if you want to read it, is let's not forget about our traditional enterprise workloads. All of this thought that we're putting into driving efficiencies with AI in mind, yes, we have to do that. I'm going to go through some frameworks, how to do that in a moment. But let's not forget about our enterprise workloads, and let's apply that knowledge there as well, because they're still consuming a lot of energy. So what I'm going to go through now is, if you remember, I said at the start, we see a lot of customers, around about 10% of AI solutions make it to production. Reason for that is because they don't have an AI strategy in place half the time. So for about 25 years, our HPE have been working with customers and the organisation that I belong to on 5 key levers of sustainable transformation. And what my team found long before I joined was that these 5 levers, essentially, we apply them when working to customers to help them look at how they can drive efficiencies broadly across their enterprise essentially. So number 1, equipment efficiency. So when we think about equipment efficiency, this is around looking, so a lot of customers don't actually look under the hood, because why would they, unless they think it's running, it's working, they're not going to look at what's going on underneath there. Now with equipment efficiency, what we see is that a lot of customers are actually using their equipment that they have purchased and they have bought with their own money at very low levels of utilization. So we have conversations with customers to say, you want to get your money's worth here, let's look at actually driving that utilization levels up, for example. And these are very high level, and then if you want to talk in depth on any of these, we can do that at lunchtime. Number 2 is energy efficiency. So when we think about energy efficiency, and this is an example, is if you're going to use a kilowatt of power, we want to make sure that we are getting the most work for that kilowatt of power. So it's starting to think about it like that. Now, again, we have customers that sometimes they look at their equipment and it's, consuming a lot of energy, tremendous amounts of energy, but actually the work that it is outputting is minimal. And I'm going to see if I can remember these stats. So there was the Uptime Institute, if you remember the graph that I showed you. They surveyed 600 data centers, and 40% of those data centers that were over 5 years old. And of those, they were consuming 66% of the data center energy, but they were only producing 7% of the work. I think I got that right. Hopefully that's landed well. So effectively, it was only producing 7% of the work and it's consuming 66% of the energy. It's screaming for a tech refresh, and also you need to actually look and make some changes. So third is resource efficiency. Now you can see this in a couple of ways. So you could see this from a human resources perspective. So people perspective, how many people have you got managing your data centers? I'm making this up, but maybe you've got 10 and you only need 5, for example. So you can look about it in that way. And the other side of where you could see this is actually how are you, in terms of the infrastructure, so how are you cooling that data center down? Are you actually ready, or should you be looking at direct liquid cooling, for example, and setting that up and changing the way in which your infrastructure is in your data center? Or heat recovery, and I know that we've got Danfoss here that will go into a lot more detail there. So again, it's how you're looking at that. So we actually only had 3 levers, so not 5, we had 3, and then a few years, as time went on, it's kind of evolved with the time. So we actually added on the last 2. So the next one is software efficiency. So for quite some time, we had the 3, and then a lot of the research out there in schools of thought and academics say that why are we not looking at the applications themselves? Because what the academics say is that about 50% of the efficiency gains, or the inefficiencies, whichever way you want to see it, actually lies within the applications themselves. So we developed this 4th lever. So you can look about it in that way. So again, looking at potentially, using more efficient programming languages and things like that. So Rust or C as an example. Now, last but definitely not least, data efficiency. So this is the 5th lever. And when we think about data efficiency, again, we're here to talk about AI. We all know that it's consuming a lot, a tremendous amount of data. So the one thing that we see as a team is when we speak to customers, whether it's in the London CIC or Houston, or whether we're just having a general meeting with a customer, we'll ask the customer, how much data do you need to stand up? And they say, most of the time they say a lot. And we say, okay, and how long do you want to store that data for? And they kind of say, again, I'm kind of being in jest here, but they say a long time. We say, okay, well, have you thought about putting a data strategy in place? Why? Because then what you can do is you can actually challenge your end users. So if somebody comes to you internally and says, we want to stand up 1 terabyte worth of storage, you can say to them, okay, why? What's that for? You can also say, how long do you need to actually store that particular data for? Because statistics actually say that customers only look at 1/3 of their data. And if we forget about work for a minute and we step out of work and you think about your phones, do you really look at all those photos on your phones? Do you use half those applications on your phones? I don't think so. And that's the same when we think back into the world of work. So putting a data efficiency strategy in place. And again, on that point as well, you can, back to the only actually looking at 1/3 of the data, you can then store it on tape if it's a piece of data that only needs to be accessed once every 10 years, for example. Why does that increase efficiencies? Because then you're not using compute power, you're not using energy, etc. Now that was a very quick whiz through of them all, but these are the 5 levers and these are the foundations before even thinking about implementing an AI strategy. Okay, so you've implemented the 5 levers. Not that quick, because it does take some time, but now what we encourage customers to do is we encourage them to optimize throughout the whole AI lifecycle. Now, there might be some customers in the room that actually start right at the beginning and actually are building from scratch. But what we tend to see is actually it's around the tuning phase that customers are at, maybe training and tuning, that's where they're kind of at with the models. But let's start from the beginning briefly. So defining. One of the things that we always say to customers is when you're defining, actually stop and think, is AI the solution that you need? Again, maybe that's controversial to say, but sometimes AI, you could solve the issue by not using AI and you're going to save the planet, essentially. And then let's say it is. So you've done that, you've defined it. Is it actually going to bring value to the organization? That's another thing as well. Is it going to bring value? Is it going to answer the questions that needs to be asked? The next point, if we go over to data, and you'll see underneath that data efficiency, so cast your mind back to the 5 levers. So this is heavy on the data efficiency side. This is all on collecting and curating the data. So again, what we tend to speak to customers and we say, you know, are you, and again, this sounds really simple, but are you speaking to the end user? Are you actually asking the end user, you know, what do they need this particular AI model for? Why? Because if you're speaking to the end users, they can actually, depending on what AI model you're creating, they can give you the resources to feed the AI model. They can actually help you build the model, and then you're going to produce something that is of value. And if we go to training and tuning, and this is where we tend to see the majority of customers are actually more so on the tuning side. Again, the training is very energy intensive, so you need to make sure that you've got, and again, cast your minds back to the 5 levers, resource efficiency, energy efficiency. They're very heavy on pretty much all of the levers. Now, if I zoom across to inferencing, now inferencing is around, again, very heavy on the equipment, energy, resource efficiency. So you need to make sure that you've got all of the foundations right there. So again, you need to make sure your equipment's up to date, you're using renewable energy if you can, and resource efficiency as well. Inferencing, slightly different from training. So the model has already been trained. And when you think about inferencing, you can't actually predict how much or how often your end users are going to inference the model. And what does that mean? It essentially means that they've got the model, it's been trained. The user or the person using the AI model is going to be feeding and showing that AI model new data and new information. As you can imagine, and hopefully you've got the gist, if I've explained it well enough, that is very energy intensive. And in the media, in the news, you do tend to see the focus on training and tuning being quite energy intensive. They are, but the most is actually inferencing. And last but definitely not least, monitor. Customers sometimes, not all, think that that's it and they've done it, all the hard work, but you need to actually keep on assessing that particular or any model that you do. And that's where agentic AI comes into place, for example. So self-learning, so that's an exciting thing as well. Okay, nearly there. So you've implemented the 5 levers, you've followed the AI lifecycle strategy. Does it stop? No, you've got to continue to minimize the impact. So heat reuse, again, I know we have Danfoss here today, so I'm not going to go into that too much, but essentially the one thing I will say is that heat used to be seen as something that, or a waste product that you wanted to get out of a data center as quick as possible. Now we know that it's seen almost as a commodity. It's something that you want to keep, it's something that you want to keep, cool down, and actually then you can reuse that heat. So there's a big change there. Renewable energy, 24/7. So again, we hear customers say to us, you know, we are renewable, we are renewable energy, we are using renewable energy all the time, but actually it's quite hard to do, because if you think about it, solar and wind, you actually need to have a portfolio of renewable sources in order to be 24/7. I keep saying this, but not last but definitely not least, the lifecycle services. So at HPE, we have got one of the largest global asset upcycling services. And this is fantastic because thinking about it from your minds, actually, as a customer, you know, I'm here talking to you about how you can drive efficiencies and how you can make sure you're reducing your carbon footprint. But actually, you then need to also think about what you're doing at the end, which is what's happening to your equipment as and when, you know, it's end of life, because that's impacting you as the customer as well. So we take back that kit. It doesn't have to be HPE, it could be anybody's. And it's not just servers, it's laptops, mice, keyboards. I've got a feeling we do phones. Could be wrong on that one, but I've got a feeling we do. Pretty much everything. And what we actually then do is we produce, we give back the customer a very detailed report, so the circular economy report. And what that shows is exactly how much you've saved in terms of carbon emissions, which is fantastic. And then you can use that internally to go internally and show the savings that you've made, as opposed to if you didn't go with that particular service. And this is a slide just to show you some of the resources. So that is the end from me. But we, as a team, we write white papers, and we've got white papers on each of the 5 levers that I described, plus more. So we've got the one in the middle, there's the data efficiency example, white paper. And on the right-hand side there, the AI efficiency, that was actually released last week. And my colleague wrote that. He worked very hard on it, and it's really, really good. And we're really open to feedback, whether it's good or bad. We want both, because we update the papers every 2 years. So that link will be sent out afterwards as well. Well, thank you very much. And I'll speak to you guys at lunchtime.